Geometric series. So geometric series, here we have a summation that n goes from 0 to infinity. I have a multiply r to the nth power that is equals to a times r when n is equals to 0 plus a times r when n equals to 1, and then plus a times r when n equals to 2, plus a times r when n is equals to 3, and then you can keep on going. So this one we can factor a out because a is not changing, so we will factor a out of the summation, just like taking a constant out of an integral. N goes from 0 to infinity, and then r to the n, and then this one we can also factor out a, and then I have r0 plus r1 plus r2 plus r3, and then keep on adding. So this is a geometric series, and then the geometric series can converge or diverge. So let's do a converge. So the first situation is the geometric series converges if the common ratio r, where the absolute value of r is less than 1, and then converges means the sum is equals to a real number, and then the sum can be found using this formula. The sum is equals to a divided by 1 minus r. And then what about diverges? And then number 2, geometric series diverges if the common ratio r, and then when absolute value of r is greater than or equal to 1. Okay, let's try a convergence. So for convergence, I will follow the orange. So this is for convergence. I have summation, n goes from 0 to infinity. I have 3 multiply 1/3 to the n. So this one is equals to 3 raised to 1/3 to the 0, and then plus 3 times 1/3 raised to the first times 3 times 1 over 3 to the second, and then 3 1/3 to the third, and then you keep on adding. This one, actually last time when I prepared the notes, I used a 2. Okay, to make them consistent, I will change the denominator to a 2. So change that to a 2. So this will be all 2. And then what is the common ratio? So before we look at the common ratio, let's take a look at this. What happens when n is very large? So for example, I have 1/2 to the 1,000, and then I have 1/2 to the 6,000. What happened to this? Or I have 1/2 raised to a very large power. So these are all approximately equals to 0, because when you have a 1/2 raised to a large power, we have 1 raised to any power which is equals to 1, and then 2 raised to a very large power like that. That will give you 1 over infinity. 1 divided by infinity is nearly 0. Okay, so that means when n is large. So when n is large, 3 times 1/2 to a large power are a bunch of values that is very close to 0. So when n is large, every single term is close to 0. So that means the sum is really determined by the first couple terms. How come this one I have an n? This one is supposed to be a 0. Because we start at 0, and the first power, second power, third power, and then we will say the sum is determined by the terms when n is small. When n is small, so that will be 3 times 1/2 to the 0 power, 3 times 1/2 to the first power, 3 times 1/2 to the second power, 3 times 1/2 to the third power. Or it's not really a third power, you can say a fifth power, and then maybe 1/3 to the eighth power, something like that. So the sum is really determined by them, and then the common ratio r is equals to 1/2, and then the absolute value of 1/2 is less than 1. So therefore, the series converges. So we say the series converges. And then what's the sum? The sum is equals to a divided by 1 minus r. A is the term that is not changing, so that will be a 3, and then divided by 1 minus 1/2, so that will be a 3 divided by 1/2. The sum is equals to 6. So you are adding up infinitely many terms. The sum is equals to 6. The series converges. Okay, then let's take a look at a divergence. So for divergence, all I need to change is this. So for divergence, I will do a summation, n goes from 0 to infinity, and then 3, I will just do a 1/2 2 to the nth power. That's all I have to do. So that is 3 times 2 to the 0, and then 3 times 2 to the first, and then 3 times 2 to the second, and then 3 times 2 to the third, and then 3 times 2 to the fourth, and then you can keep on adding, but you will reach to terms like this. 3 times 2 to the maybe 200, and then you keep on adding, you will have 3 times 2 to the 1000, and then you can keep on adding, you will have 3 times 2 to the maybe a 10,000, and then you are still keep on adding. So let's take a look at these terms. So every single one of this, let's pick a different color to draw the observation. So every single one of this, we have 2 raised to a very large power, right? So this term, so the 2 raised to 200, and then the 2 raised to 1000, all these are infinity. And then the sum of many infinity is just equals to a very huge infinity value. So the sum of this term, when the exponent is large, is equals to infinity. And then we will say the series diverges. So the series diverges. A more formal explanation is you have to point out that the common ratio is equals to 2. The absolute value of 2 is greater than or equal to 1. So therefore, the series diverges. So that means the sum is equals to infinity. There is no need to use this formula anymore because of this large quantity, then the sum is equals to infinity, and then it is not necessary to use any of those values. But can we add 2 geometric series together? Yeah, we can do that. So let's do another example. I have a summation n equals to 0 to infinity, 0.25 to the nth power plus 6 to the nth power. This one is just like the integral of 2 terms. You can break that down into 2 individual integrals. Likewise, you can break that down into 2 individual sums. The first one will be a summation, n from 0 to infinity, you have 0.25 raised to the nth power. And then because we are adding up the 0.25n and the 6 to the n, this is a plus. The summation, n goes from 0 to infinity, 6 to the nth power. And then they are both geometric series. If you want to find out what the a equals to, we can simply do that. So how about I will just duplicate this, and then give myself some space in front of each of this. And then I will just do let's say, how about I do a 1 in here. Okay, let me just write a 1 in here, and then this, I will write a 1 in here. So putting a 1 in there doesn't change anything. And then for the first series, I have the common ratio equals to 0.25, absolute value of 0.25, that is less than 1. So that means the series converges. And then what's the sum? The sum is equals to a divided by 1 over r, which is a 1 divided by 1 minus 0.25, and then that is 1 over 0.75. This is a 1 over 0.75 is 3 over 4, reciprocal, that is 4 over 3. So that gives you the sum of the first series. And then the second one, this one, the common ratio is 6. The absolute value of 6 is greater than is greater than or equal to 1, and then that means the series diverges, and then the sum is equals to infinity. So we have a sum equals to infinity, and then the sum equals to that. So what is the sum? When you add that infinity plus 4 over 3, that means the entire series, the sum is infinity. The sum is infinity. So that means the entire series as a whole, the entire series diverges. That's all. And then you may, some people ask me this before, hey, you have a greater than or equal to 1. Can we try the 1 really quick? Yeah, you can try the 1 really quick. So what you can do is, I'm trying to pick a color to do that. So how about I pick this, orange. So let's say we have a summation. N goes from 0 to infinity. I have 2 times 1 raised to the n power. So this is 2 times 1 to the 0 plus 2 times 1 to the first plus 2 times 1 to the second, right? Everything looks fine until you reach to this 2 times 1 raised to 100 power, and then you keep on adding. You will have 2 times 1 raised to 1,000, and then plus 2, keep on adding, and then 2 times 1 to the 10,000. And then you are still keep on adding. Notice that 1 to a very high power is equals to 1, right? 1 raised to 1 million power. 1 times itself a million times. That is still equals to 1. Yes, I got that. But this one, yes, that is still equals to 1. So this one will be the sum of many copies of 2 times 1, the sum of many copies of 2, infinitely many of them. So that will be similar to 2 times an infinity, which is equals to infinity. Yes, although this one, when you add them up, the sum is not going to become infinity, but as n becomes very large, we are adding up infinitely many copies of 2. So this one, the sum, the common ratio, okay, match the color, R is equals to 1, absolute value of 1 is greater than or equals to 1, so the series diverges. And then the sum is equals to infinity. All right, so this is the end of this video. I just gave you a basic introduction to geometric series. All right, I will see you in the next video for more topics like this.